Good day, ma'am. Good day, classmates. Good day, everyone. Welcome to our learning session, wherein I will be discussing one of the cognitive theories in mathematics education. And the cognitive theory I chose to discuss is the theory of cognitive development proposed by John Piaget. And to support my presentation, allow me to present to you an article which is all about applying Piaget's theory of cognitive development to mathematics instruction. This article was presented by or authored by Dr. Bobby Ojose. Dr. Bobby Ojose is an assistant professor at the University of Redlands, California. He teaches mathematics education and quantitative research method classes. His research interests encompass constructivism in teaching and learning mathematics. This article was presented and given at the National Council of Teachers of Mathematics, or the NCTM, in 2005 in Anaheim, California. It explicates the developmental stages of the child as proposed or posited by Piaget. The author then ties each of the stages to developmentally appropriate mathematics instruction. The implications in terms of not imposing unfamiliar ideas on the child and importance of peer interaction are highlighted in this article. So allow me to present here the introduction of the article. According to the author, John Piaget's work on children's cognitive development, specifically with quantitative concepts, has garnered much attention within the field of education. That is why John Piaget is a well-known personality in the field of education. One of his contributions concerns the developmental stages of the children's cognition. These developmental stages will be discussed later in the succeeding slides. His works on children's quantitative development has provided mathematics educators with crucial insights into how children learn mathematics concepts and ideas. Piaget believed that the development of a child occurs through a continuous transformation of thought processes. A developmental stage consists of a period of months or years when certain development takes place. Although students are usually grouped by chronological age, their development levels may differ significantly, and that was according to Weinert and Helmke in 1998, as well as the rate at which individual children pass through each stage. And this difference may depend on the maturity, experience, culture, and the ability of the child. That was according to Papila and Olds in the year 1996. According to Burke in 1997, Piaget believed that children developed steadily and gradually throughout the varying stages, and that the experiences in one stage form the foundations for movement to the next level. So, meaning to say that one or each of the stage is essential in the formation of another stage. All people pass through each stage before starting the next one. No one skips any stage, and that was according to Egan and Kauchak 2000 in year 2000. So to further understand the developmental stages proposed by John Piaget, allow me to present to you this. So these are the stages of cognitive development. The first stage is the what we call sensory motor stage, or from birth to up to 2 years of age. The second stage is the pre-operational stage, or from 2 years up to 7 years of age. The third stage is the concrete operation stage, from 7 years of age up to 11 years of age. And the last stage in the development theory is the formal operation stage, or this is from 11 years old and above. So let us have these stages one by one, starting with sensory motor stage. In this stage, an infant's mental and cognitive attributes develop from birth until the appearance of language. Usually, this is from birth up to 2 years of age. This stage is characterized by the progressive acquisition of object permanence, in which the child becomes able to find objects after they have been displaced, even if the objects have been taken out of his field of vision. For example, Piaget's experiments at this stage include hiding an object under a pillow to see if the baby finds the object. An additional characteristic of children at this stage is their ability to link numbers to objects, according to Piaget in 1977. Example, 1 dog, 2 cats, 3 pigs, 4 hippos. So at this stage, their knowledge on numbers are being developed. To develop the mathematical capability of a child in this stage, of course, it is very important for us as teachers. The child's ability might be enhanced if he is allowed ample opportunity. Ample opportunity to act on the environment in unrestricted but safe ways in order to start building concepts. And that was according to Martin in the year 2000. Evidence suggests that children at the sensory motor stage have some understanding of the concepts of numbers and counting, from Fuson in year 1988. As teachers, educators of children in this stage of development should lay a solid mathematical foundation. As I was saying a while back, each stage is very important. Each stage is very essential. Each stage is very crucial in moving to the next stage of the development. Okay? Providing activities that incorporate counting and thus enhance children's conceptual development of numbers. So, according to some experts, we should be providing activities that incorporate counting or to develop the conceptual development of number to a child. For example, teachers and parents can help children count their fingers. That's simple. Toys and candies. Questions such as who has more or are there enough could be a part of the daily lives of children as young as 2 or 3 years of age. It is also very important that we connect the concept of numbers in our daily lives. Another activity that could enhance the mathematical development of children at this stage connects mathematics and literature. So, as teacher, we should learn this because we are dealing with infants. Especially this recommendation is for parents because these children aging from 0 to 2 are still at home. There is a plethora of children's books that embed mathematical content. This is a recommendation, or a recommendation would be that these books include pictorial illustrations because children at this age can link numbers to objects. Learners can benefit from seeing pictures of objects and their respective numbers simultaneously. Along with the mathematical benefits, children's books can contribute to the development of their reading skills and comprehension. So, this plethora of children's books or books with pictorial illustrations connected to literature will help our children or will help these infants develop their mathematical concepts as well as their reading skills and comprehension. The next stage in the cognitive development theory proposed by Jean Piaget is the pre-operational stage. Just like what I have said, this pre-operational stage involves children aging from 2 to 7 years of age. The characteristics of this stage include an increase in language ability, symbolic thought, egocentric perspective, and limited logic. In this second stage, children should engage with problem-solving tasks that incorporate available materials such as blocks, sand, and water. So from 2 years of age to 7 years of age, there is some of them who are already in school. So it is very important as parents and teachers to give activities that involves them in problem solving tasks. Okay? While the child is working with a problem in problem solving, the teacher or the parent should elicit conversation from the child. The verbalization of the child as well as his actions on the materials gives a basis that permits the teacher to infer the mechanism of the child's thought processes. In the pre-operational stage, there is lack of logic associated with this development or stage. And rational thought makes a little appearance in pre-operational stage. The child links together unrelated events, sees objects as possessing life, does not understand point of view, and cannot reverse operations. For example, a child at this stage who understands that adding 4 to 5 yields 9 cannot yet perform the reverse operation of taking 4 from 9. Meaning to say that the children's perception in this stage of development are generally restricted to one aspect or dimension of an object or a problem at the expense of the other aspects. For example, Piaget tested the concept of conservation by pouring the same amount of liquid into two similar containers. When the liquid from one container is poured into a third or a wider container, the level of the water or the liquid is lower, and the child thinks that there is less liquid in the third container. Thus, the child is using one dimension. The dimension that the child is using in that experiment is the height as the basis for his judgment of another dimension, which is the volume. To develop the mathematical capability of a child in this stage or the pre-operational stage, we have to be teaching students in this stage of development employing effective questioning about characterizing objects. Just like what I have mentioned, students or children at this stage are using only one dimension. That's why it is very important that we employ effective questioning about characterizing objects. For example, when students investigate geometric shapes, a teacher could ask students to group the shapes according to similar characteristics. Questions following the investigation could include: how did you decide where each object belonged? Are there other ways to group this together? Engaging in discussion or interactions with the children may engender the children's discovery of the varieties of ways or the variety of ways to group objects, thus helping the children think about the quantities in novel ways. That was according to Thomson in year 1990. The third stage of the cognitive development theory by John Piaget is the concrete operations stage. So this is from 7 to 11 years old. The third stage is characterized by remarkable cognitive growth. When children's development of language and acquisition of basic skills accelerate dramatically. Children at this stage utilize their senses in order to know. They can now consider 2 or 3 dimensions simultaneously instead of successively. Unlike in the previous stage, the child is using one dimension only in solving a problem. So in this case, the child can now consider 2 or 3 dimensions so they can evaluate the problem or a situation in a good manner. For example, in the liquids experiment, if the child notices the lowered level of the liquid, he also notices the dish is wider, seeing both dimensions at the same time. Additionally, seriation and classification are the two logical operations that develop or that could be developed during this stage, and that was according to Piaget in the year 1977. And both are essential for the understanding of number concepts. Seriation, it is the ability to order objects according to increasing or decreasing length, weight, or volume. While on the other hand, classification involves grouping objects on the basis of a common characteristic. So these are the two logical operations that could be developed in this stage: seriation and classification. To develop the mathematical capability of a child in this stage, according to Burns and Silbe in year 2000, hands-on experiences and multiple ways of representing a mathematical solution can be ways of fostering the development of this cognitive stage. So hands-on experiences and multiple ways of representing a mathematical solution. The importance of hands-on activities cannot be overemphasized at this stage. These activities provide students an avenue to make abstract ideas concrete, allowing them to get their hands on mathematical ideas and concepts as useful tools for solving problems. Because concrete experiences are needed, teachers might use manipulative or sets of manipulative with their students to explore concepts such as place value and arithmetical operations. Existing manipulative materials include pattern, blocks, Kusinea rods, algebra tiles, algebra cubes, geoboards, tangrams, counters, dice, and spinners. However, teachers are not limited to commercial materials. They can also use convenient materials in activities such as paper folding and paper cutting. As students use the materials, they acquire experiences that help lay the foundation of more advanced mathematical thinking. Furthermore, students' use of materials helps to build their mathematical confidence by giving them a way to test and confirm their reasoning. Or in this stage, by the use of these materials, we can help them develop their skills in reasoning. Providing various mathematical representations acknowledges the uniqueness of students and provides multiple paths for making ideas meaningful. engendering opportunities for students to present mathematical solutions in multiple ways. Example of this are the use of symbols, graphs, tables, and words is one tool for cognitive development in this stage. Egan and Kauchak in year 2000 noted that while a specific way of representing an idea is meaningful to some students, a different representation might be more meaningful to others. The last stage is the formal operation stage, or this involves students or children from 11 years of age and above or up. The child at this stage is capable of forming hypotheses and deducing possible consequences, allowing the child to construct his own mathematics or his own reasoning. Furthermore, the child typically begins to develop abstract thought patterns where reasoning is executed using pure symbols without the necessity of perceptive data. For example, the operational learner can solve x plus 2x equals 9 without having to refer to a concrete situation presented by the teacher, such as Tony ate a certain number of candies, his sister ate twice as many. Together, they ate 9. How many did Tony eat? According to John Piaget, in this stage of development, the children or the students can use abstract or can make use of symbols in solving problems. Reasoning skills within this stage refer to the mental process involved in the generalizing and evaluating of logical arguments, and that was according to Anderson in year 1990, and include clarification, inference, evaluation, and application. So these mental processes, the clarification, the inference, evaluation, application are important components of the last stage. Starting with clarification, clarification requires students to identify and analyze elements of a problem. And this mental process also allowed them to decipher the information needed in a solving problem or in solving a problem. In this mental process also, by encouraging the students to extract relevant information from a problem statement, teachers can help students enhance their mathematical understanding. Next is the inference. The mental process that is characterized by students at this stage are developmentally ready to make inductive and deductive inferences in mathematics. Deductive inferences involve reasoning from general concepts to specific instances. On the other hand, inductive inferences are based on extracting similarities and differences among specific objects and events and arriving at generalizations. The next process is the evaluation, which involves using criteria to judge the adequacy of a problem solution. For example, the student can follow a predetermined rubric to judge the correctness of his solution to a problem. Evaluation leads to formulating hypotheses about future events, assuming one's problem solving is correct thus far. The last mental process is the application, and it involves students connecting mathematical concepts to real life situations. So it is very important as teachers to make connections of our lessons in real life situations. In that way, students can relate, especially nowadays that there are lots of distractions to students, the gadgets, online games, social media, That's why their attention span is very short. It is very important that we make connection of our lessons to what they are doing in real life situations. For example, the student could apply his knowledge of equations to the following situation. You can clean your house in 4 hours. Your sister can clean it in 6 hours. How long will it take you to clean the house working together? So the problem is contextualized and conceptualized according to or in connection to real life situations. So in this case, the students or the children can relate to the problem, and that way we can lead them to solving the problem correctly. And that would be all. Thank you so much.